The atmosphere. Learning target number 3 for the atmosphere is I can explain how heat is transferred in the atmosphere. Your essential vocabulary is heat transfer, conduction, convection, and radiation. Heat transfer is the exchange of heat energy between two physical systems with different temperatures. The rate of how fast the heat transfers completely depends on the temperature of the two systems and what the systems are made of. So, the bigger the difference in temperature between the two systems, the faster the transfer of heat. Heat transfer always goes from hot to cold, hence the term heat transfer. Eventually, if no more heat is added, the two systems will become the same temperature. Generally, there are 3 types of heat transfer. You have conduction, convection, and radiation. In all 3 types of heat transfer, there will be an exchange of heat which causes change in the energy from one system to another system. Energy can neither be created nor destroyed, just moved around. Let's begin with the type of heat transfer conduction. Conduction is the transfer of heat by direct contact. For instance, when we reach for and grab a cast iron pan on the stove, the temperature of your hand is much cooler than the cast iron pan. When we touch the pan, the heat energy gets transferred from the hot pan into your hand. Here's another example. Heat from the fire is transferred through the metal rod to your hand, ultimately burning your hand. This is why we use things like wooden spoons, plastic pan handles, and oven mitts. These are called insulators and do not transfer heat energy very easily. Most people think conduction is the only mode of heat transfer between two bodies, but their assumptions are completely wrong. Conduction is the best and effective way of heat transfer, but there is another way which is approximately equal to the effect of conduction, known as convection. In order to understand convection, we must first understand what happens when temperature of gases or liquids change. As gases or liquids cool, the molecules slow down and move closer together, just like when you shiver or shake or you're cold and you put your hands together and around yourself. As the molecules heat up, they speed up, bounce into each other, and spread apart. A great example of convection is a hot air balloon. The basis of how the balloon works is that warmer air rises in cooler air. This is because hot air is lighter than cool air and it has less mass per unit volume. To keep the balloon rising in the air, hot air needs to be propelled upward using the burner. The pilot must keep firing the burner at regular intervals throughout the flight to ensure the balloon continues to be stable. Naturally, the hot air will not escape from the hole at the very bottom. To move the balloon upwards, the pilot opens up propane valve, which lets the propane flow to the burner, which in turn fires the flame up into the balloon. The bigger the flame to heat the air, the faster the balloon rises. To move the balloon downwards, the parachute valve at the very top of the balloon is what is used to bring the balloon down towards the ground. It is a circle of fabric cut out of the top of the balloon, which is controlled by a long cord which runs down the middle of the balloon to the basket. If the pilot wants to bring the balloon down, he simply pulls on the cord, which will open the valve, letting hot air escape, decreasing the inner air temperature. This cooling of air causes the balloon to slow its ascent and eventually causes it to descend towards the ground. In this demo, you can see that as the colder molecules come together, the density increases, causing them to sink due to gravity. The opposite is true of hot air or liquids. As the molecules spread apart, the density decreases, causing the molecules to be pushed up by the colder molecules that are sinking. This is convection. The best example of convection is heating cold water through a pan kept on the stove. First, the bottom layer of the pan gets heated up. The heat of the pan gets transferred to the bottom layer of water. We know that when its temperature increases, density decreases. So the cold water present at the top of the pan changes place with the hot water at the bottom. As cooler water sinks, it gets heated by the flame and warms up again. This cycle continues until the heat source is turned off. For convection, you always want to think circles. Another example is crawling on the floor during a fire. We know that hot air expands, then rises, and cold air compacts, then sinks. In a fire, the hotter smoke rises and the cooler oxygen sinks to the ground. Radiation is the final mode of heat transfer. Radiation is usually the transfer of heat from one place to another place through waves. Radiation has no obstructions. They can even penetrate through solid objects to reach their targets, as you can see here with the heating coils underneath the tile floor. This does not include the motion of or movement of particles. Other examples include radiation from the sun that heats the earth, sun tanning, and cooking food and warming up by a campfire. You can feel the heat. Thanks for sharing or listening.